Okay, so in this video, we talk about the chapter of differentiation, and more specifically, the topic that we'll be talking about deals with equation, equation of tangent, and equation of normal. So this is additional math differentiation. So the concept we'll be talking about deals with equation of tangents and normals. Now, what exactly are tangents? Now, if you look at this graph, if you take a look at this curve over here, um, right over here, a tangent is basically a line that touches the surface of the curve and then goes away. So, so for example, if I were to draw a tangent at this point, it would look it would look somewhat like this. A, a better line would be something basically touch this point. So this is basically the tangent, and you can imagine the line could be drawn better. And for example, if you were to draw a tangent right over here, it would basically be a horizontal line, touch and go. If we were to draw a tangent somewhere over here, the tangent would look somewhat somewhat like this. So if you take a look, you can see how the three tangents have three different uh, gradients, steepness. This one being one with a positive gradient, this one being one with the negative gradient, and the horizontal one being a line with zero gradients. Now, where does differentiation come in when it comes to tangents and normals? Well, before we go into what a normal is, let's recall what differentiation actually gave us. Recall that if you had equation y equals x squared plus 5x plus 6, dy by dx gave us the expression for gradient of tangent, right? So if I were to differentiate this with respect to x, we would get 2x plus 5, which essentially would be the expression for the gradient of tangent to this particular curve. What this means is when you, for example, plug in x equals to 1 and get the value dy by dx to be 7, and for example, when you plug in x equals to minus 1 and get dy by dx to be 3, what this essentially means is for this curve, if you took the gradient at x equals, let's say, x equals 1, the tangent would have a gradient of 7. But if you took it for x equals to minus 1, the gradient of the tangent would be 3, this one being 7, so this one being steeper, right? So that is what this differentiation does, and that is the major application of differentiation. Whenever we have the equation of a curve, we differentiate it, we get expression for the tangent's gradient. It's always the tangent's gradient first, and plug in an x value and you get the value for the gradient of the tangent. So keeping that in mind, let's let's recall what we already knew from coordinate geometry. We knew from coordinate geometry that equation of a straight line follows y minus y1 is equals to mx minus x1, which means if you have a line connected by 2 points A and B, one such point has an x coordinate and the y coordinate. And when you plug them in here as x1 and y1 and plug in this line's gradient in place of m, you get an equation connecting y with x. Example, y equals 3x plus 7. All right, this is what you would get when you plugged in the appropriate values in place of y1, x1, and the gradient, right? This is the way to go about figuring out the gradient of a straight line, sorry, the equation of a straight line. So connecting what we just learned from differentiation and what we remember from coordinate geometry, we can figure out the equation of a tangent of any curve, because a tangent is a straight line, thus it would follow this equation, right? Now, let's take a look at an example, and the example is this. For the curve y equals x squared plus 5x plus 6, find the equation of find the equation of tangent at x equals, let's say, 3. All right, so we already have an x coordinate. So what this essentially means is, look, I have a curve right over here, x squared plus 5x plus 6, but I want to figure out the gradient of the tangent, sorry, the equation of the tangent at this point, 3. So I want to find the equation of this line, this tangent over here at x equals to 3. So remember, this tangent is a straight line, so it must follow that this tangent must follow this particular equation, right? Now, we need three pieces of information to find the equation of this tangent. The first piece of information is an x coordinate, which through which our tangent passes. We need the corresponding y coordinate, and we need the gradient of the tangent. Now, some of the information are already given to us. For example, the 3, right? The x coordinate, one of the x coordinates through which our tangent passes is given. It's 3. We also want to find the y coordinate, and since we know the equation of the curve, and notice how the curve and the line are meeting at the red dot over here, we can figure out the y coordinate at x equals to 3 by substituting x equals to 3 here and here, because the equation will also give me the y coordinate of the curve, which is right over here. So the y coordinate is where on the curve the x coordinate is 3, right? So 3 square plus 5 into 3 plus 6. So that's a 9 plus 15 plus 6. Guess what? It's a 30. Meaning at this point where x is equals to 3, the y coordinate is a 30. So there you go. We have the y coordinate, right? Now for the gradient, and obviously, I mean, the reason these questions are in the chapter of differentiation is that differentiation plays a role when it comes to finding the gradient. And we know that if we want to find the gradient, we need to differentiate the curve. So what is the differentiation of this particular curve? X squared differentiates to 2x, and the 5x differentiates to positive 5, and the 6 differentiates to 0. Ultimately, at x equals to 3, since we want to find the gradient at x equals to 3, the value of the dy by dx comes out to be 11. And this is also the gradient of the tangent. So there you go. We have the three pieces of information that we needed in order to fill up the equation of a straight line formula. So we have the equation, sorry, we have the x coordinate from the question. We plug it into the main equation of the curve to find the y coordinate. We use our knowledge of differentiation to find the gradient. Now just plug them all in here because it's a straight line. So y minus 30 um, is y minus 30 is equals to the gradient, which is 11 x minus 3. Ultimately, this boils down to term negative 33 plus negative 33 plus 30. So the answer is y equals to 11x plus 3. So hopefully that clarifies the idea of how to figure out the equation of the tangent. Once you figure out the equation of the tangent, they may ask you questions related to coordinate geometry. For instance, where does the tangent cut the x-axis? Where does the tangent cut the y-axis, right? So you need to have a decent grasp of coordinate geometry if you want to solve these questions properly. But initially, at the very beginning, what you need to understand is that dy by dx gives us the gradient of tangent all the time, and because tangent is a straight line, it will always follow this particular equation. And together, by combining the chapters of differentiation and coordinate geometry, we can come up with the equation of a tangent. Now, the same idea can be applied for normals, okay? Now, what normal is it's essentially a line that is perpendicular to a tangent. So for example, the tangent at this point looks somewhat like this, right? The normal would essentially be perpendicular to this. Well, that's not the best perpendicular line, but the angle between them, the green line and the blue line, has to be 90 degree. So if this is our tangent, obviously because the green line touches the curve, this is the normal. The normal doesn't have to touch the curve. Well, it will touch the curve, but it will go through the curve, right? Because it is perpendicular to our tangent. So this right here is our normal. The only connection between the tangent and the normal at the same point is that they are perpendicular to one another. Again, from coordinate geometry, we can say the gradient m of the tangent, mt, multiplied by mn, the gradient of the normal, is equals to negative 1, right? Minus 1. Where do we get this from? The chapter of coordinate geometry, which says the gradients of two perpendicular lines always multiply to give us a negative 1. Now, why is this important? Let's say in that very question, I asked you not to give me the equation of the tangent, but for the normal at x equals to 3. What if I had asked you for the equation of normal at x equals 3? Well, once again, normal is also a straight line, right? So y minus y1 is equals to mx minus x1 is our way to go about. And once again, we need three pieces of information. Uh, an x coordinate, a y coordinate, and the gradient in this case of the normal, right? Because I'm going to because we're trying to figure out the equation of the normal, right? So what is the y coordinate? It's the same, right? Because notice how the normal and the tangent are intersecting at the same point. So in the previous question, we figured when x is equals to 3, y is equals to 30, so it will be the same in this question. So whether you're finding the tangent or the normal's equation doesn't matter. These two will always be the same as long as the x coordinate is the same. It's the gradient that's going to change. So we already know that the tangent's gradient came out to be 11 in our case, and we will always start off by finding the tangent's gradient. Even if we are asked to find the equation of the normal, we'll always start off with the equation with the gradient of the tangent, and then multiply it with the gradient of the normal, which is unknown, and will give us negative 1. Tar mane, meaning the gradient of the normal is going to be negative 1 by 11. This was the missing piece of information, right? So we will again fill this up and basically try to give it a decent format, plus 30, and hopefully the answer is correct when I do it. So that is 33 and 0. And ultimately this settles to 333 by 11 minus x by 11. All right, this is one of the ways you can write the answer. But hopefully, the concept is clear to you. I mean, whenever they give you the question and they ask you to find the gradient, the equation of the normal, basically find out the x coordinate, look for the x coordinate in the question, find out the y coordinate by plugging into the main equation, and then find the gradient of the tangent first. Find the gradient of the tangent first by differentiating, and then do this process of negative reciprocal, meaning this process, and find out the gradient of the normal. And once you have all these pieces of information, the three pieces of information, you can use the straight line formula. So this is the essence of the next of the subtopic I wanted to talk about today. It was all about equations of tangents and normals. And if you are doing Li Peng Yi's book, I think the exercise is uh, 13E or 13F. I can't exactly recall. All right. So that is basically where you'll find questions about equations of tangents and normals. All right. Thank you very much.